our last speaker for today and the whole meeting is Jeremy Magland from CCM. He's going to talk about collaborative scientific visualization in the browser with FWAM.
FWAM. Thank you. Yeah, I'm happy to present on this work that I've been working on for the last couple of years with Jeff Sewells. And feel free to ask questions as we go through the presentation. I'll tell you if there's too many questions, but I don't think that's going to be the case. And we might even be able to start the weekend a little bit early. Okay, so visualization, I think, as all of you would appreciate, it's very important as part of the scientific process. So from data exploration to quality control, just communicating results and all kinds of things that are really visualization is crucial for. And especially interactive visualization. So mainly when we publish papers or distribute figures, it's often not interactive, right? We would like to be able to send all of our data for somebody else to visualize to somebody else, but often we just send like a JPEG or a static image. But interactive visualizations have a lot of benefits. You can explore very large data sets. As we've seen in Aaron's talk, you can just explore parameter space, gain intuition about a data set, and do things that you would never be able to see in a static image. But there are limitations in sharing interactive visualizations. So often you need specific operating system or hardware. I think the biggest problem is that you need specialized software often, and that's difficult to install. You might need to, if you're going to share an interactive visualization with somebody, they might need to have the actual data set. The software expects the data set to be there, and transferring all the data is annoying and difficult. And it can often require expertise in setting up the software that does the interactive visualization to reproduce that. So as we've seen, a lot of people are gravitating towards web-based software, particularly because it's easy to use. Everybody has a browser. It's cross-platform. And there's advantages from the developer's perspective. If you have a web application that you can just make changes, maybe it's a little scary for the users, but the developer can just make changes and push those to the website. It naturally works with cloud resources, and generally the web-based systems are good for reproducibility. Limitations, I'm not going to really spend time talking about those because I'm devoted to web-based platforms, so we're not going to talk about what are the downsides to that. So here's a bunch of browser-based visualization tools, and we've seen some of these already. These are powerful tools, but in order to actually use them for sharing an interactive visualization with somebody else, they need to be embedded in some sort of framework. So I'm just going to randomly choose one of these to click on to get to the website, semi-randomly. And it's always going to be a website that says, it's really easy to use this software. I mean, it's great. They bend over backwards to make it super easy to install. And, you can even get started with this by clicking a button probably. Okay, go back here. I could click on another one of these and it's the same story, like really easy to install. You can just get started coding with it. But if I have some data and I create a visualization, how am I going to get that visualization to somebody else? Like I can't just send them to the Recharts website and say, download this, because it needs to be embedded in some sort of application. And that's sort of the challenge that, that we set out to tackle here. So executable notebooks are, that's one of the most popular browser-based solutions. And the advantage is that it's, reproducible, self-documenting, interactive. You can share it on GitHub even. It's really great that GitHub will give a static rendering of your notebook, Jupyter Notebook. There's other systems for rendering some interactive capabilities, but they have limitations. The main cons of running like a full notebook and sharing that with somebody is that it requires a running backend. Also, notebooks can be cluttered by code. I'm not sure if you want to share just the figure with somebody, it's not that convenient if there's all this extra code nearby. So Binder is a great tool for making notebooks shareable. And I just have a screenshot here, and it's like very tempting to be able to just click on Launch Binder. And the promise there is that you get the notebook, and you know, nobody really has to host the binder because there's a service, My Binder. And yeah, so it's great to be able to allow authors to create interactive versions of their code, just put it in a GitHub repository. And you know, binders, if somebody's paying for it, I suppose, it can scale to many users at once, and there's a lot of advantages of it. So how it works is that you put your notebook and your code in a Git repository. You specify the dependencies using requirements.txt or environment.yaml in a certain specific place in the repo. And then you just give Binder a point, you know, you point to that repo, and Binder will create a Docker image with all your dependencies in it. It will launch the instance of that Docker image and provide an interactive session, usually for like Jupyter notebooks. And you can just fiddle around with the code. You can execute the notebook. I'm sure many of you have done this. And any changes that you make, you don't have to worry because those are ephemeral. And when you close it, all the data is lost. So there are limitations. So depending on the number of users or number of views, it can be expensive, as I mentioned. And somebody's got to maintain the infrastructure. Users need to wait for the backend to start. So I think for me, this is the most difficult thing about Binder. So here's the fastest one I could find. So matplotlib.org has a really great Binder button where you can start playing around with matplotlib, right? So we'll click on that. It starts building the Docker image. And this is really cool because it says container image already present on the machine, which is great because it doesn't even have to download it, I suppose. It just already has the image there. But maybe if you've been counting, it's been about 10 seconds or 12 seconds, 15 seconds. And so, okay, it's not even ready yet. Okay, there we go. Here we go. We almost got the visualization. Okay, and then you're free to start playing around with it. I mean, maybe it should be okay to wait that long, but so 30 to 90 seconds. I mean, if it's a really impressive visualization, you're willing to wait a minute, right? But it's not really what I'm trying to get at with sharing visualizations. You want to just share a link and then it displays. So the first Git, I don't want this to be Binder bashing talk, but the first Google hit for a live Binder is part of this kind of intro to Binder article, and it's from 2017, so you can't really expect it to work. But so this is an example where the image was not found on the machine, and so it has to build it. Now it's at step 39 out of 52 in building it, and unfortunately there was a change in the pandas Python package, so we're not going to be able to see it. And I'm sort of interested to know like what percentage of Binder links are broken on the web. So here's another one. This is a great, very powerful kind of tutorial Binder. And I click on this interact button here. And this is really, it's got a lot of, you know, calculations in the notebook that require all these libraries. So now it's on step 39 out of 52. And I didn't actually wait for it to finish all 52 because it was just taking too long. So anyway, just to give an idea of what, as I said, I don't want it to necessarily be so negative about Binder because there are a lot of advantages of it too. Okay, so moving on to this other framework. So Observable solves this problem. I don't know if you've used this, but you can go to the notebook, you share a link with somebody, and let me click on this. And I immediately see the notebook. I didn't have to wait even 10 seconds. And now I can start playing around with these kind of widgets here. And it's really, really nice. And I haven't used it myself to compose notebooks, but yeah, Alex sent me a link of something that's pretty impressive. And you can click here to expand the source code that is generating this visualization. So it's all kind of contained within itself and very responsive and everything. So that's pretty exciting. I wonder where my original page went. Oh, here we go. So there's obvious advantages in terms of collaboration. reproducibility, sharing and publishing, disseminating your findings. The limitations is that it uses modified JavaScript. So I feel like that's the main limitation. If I want to start creating some, I mean, it's observable specific JavaScript, and it's got, I mean, they really, I think, must have done a really good job in creating that because a lot of people use it. But if I just have like I want to use one of those fancy JavaScript libraries that I was on that page, I don't think you could use any of them because that really requires kind of downloading those packages, and observable doesn't do that. So there's also some performance issues I read for large data sets. And the thing is that visualization still must be embedded in notebooks. So here's another approach which was very inspiring to me, which is NeurogLancer project from Google. And here, there's no backend server required. So it's completely client-side, everything except downloading the data. So like a one-time download of data. So let me click on here to open the viewer. And isn't this really exciting? You immediately get the data, and then you can start, as it's loading, you can start kind of rotating this and everything. So it's just a pleasure to share this URL with somebody. And then you just click on it like it's an image, and you get this very rich interaction here. So if I look at the URL that I'm sharing with somebody, it's pretty cool. It's got all this information in it, right? Including the path on a Google storage bucket of where the data is. So it's very straightforward. It's like, here's the data, here's the view that I'm looking at, all these parameters, and maybe the URL could get pretty long, but it doesn't really matter. You send it to somebody and they click on it, right? So there is a limit to the size, yeah. So you couldn't embed the actual data in the URL. Yeah. Okay, so there are some limitations. First of all, NeurogLancer is a specialized tool, so you can use it to view the stuff that NeurogLancer lets you view, and it requires data to be prepared. Like if I'm the recipient of the URL, that's perfect. But if I'm creating the URL, I've got to find a way to get that data up to a Google storage cloud or whatever S3 bucket. And that requires expertise in configuration. And I'm sure there are tools to help kind of automate that, but it's just a task that needs to be done. So this brings me to FigURL finally. So the goal here is to simplify sharing of interactive figures. So you run a Python script and generate a shareable URL, and then use the clickable hyperlink method to then distribute that to somebody else, just like NeurogLancer. So no backend server. Hopefully it's loading quickly. And you can create custom visualization plugins. So you're not just limited to what, like for example, NeurogLancer created with their website, but it's really a pairing between a custom web visualization and the data. So here's an example, a Plotly example. So in Python, you can create a Plotly figure here. And then instead of saying, I think figure.show, you wrap this in a FigURL Plotly object. And then you generate the URL from it. And then it gives this link here, which I can click on. And we have this kind of Plotly view that I can just share with anybody. And yeah, so that works for the entire library of Plotly. So I could also embed it in this presentation, for example. It's just an iframe, so got it there. And then there's this other widget. This is specific to neurophysiology, so it's domain-specific visualization, but it's very straightforward, right? Oops. So here's how it works. So Python script that is being used to generate the figure creates a data blob that is needed by the visualization. It then uploads that to a content addressable storage database, which I call cachery. It then generates the URL link. And when that link is opened, it's a pairing between the data that comes down from the storage database and the visualization plugin. Those come together in the FigURL website. and it just sort of pairs them together. So here's a more kind of involved example from neurophysiology, and I will just open this. This one takes a little bit longer for the data to load, but you can, for the data that has loaded, you can immediately start kind of interacting with it. Go to this other tab. You can select all these units, and they highlight in these other plots. And I'm just showing you like the sort of richness of what you can achieve here. But selects multiple of these, and you get all these different kind of synchronized views. So how to create that example? So there's a package called Spike Interface for dealing with this neurophysiology data, and you load it into a widget that if you're in a Jupyter setting, you could then show that widget inside the Jupyter notebook, or you can generate a URL and print it out and then share it with somebody. So this is especially useful when you have like something running on a compute cluster or in cloud resources or something where you want to be able to visualize something, but you don't want to just generate a figure that or a static image that you later would kind of download from the results. You could have the process print out the URL, generate the figure URL, print out the URL, and then in your log, you could just click on that and get the output of your process. Yep.
This page works because you've inserted into the Spike extractors or the Spike interface a fig URL widget generator or something.
Exactly.
Okay.
Yep. Yep.
Because you happen to be a developer on Spike interface too.
Yes. So you can't just take any package that displays something in Jupyter and then make it a figure viewable. If it's Plotly, you can. If it's Altair, you can. But each visualization needs to be developed separately. So here's how the URL is structured. So figureL.org, that's the kind of parent website. Then v equals, and then it's the URI pointing to the visualization plugin. So you'd have it like an index.html there. And then you have d equals, and then this is the content addressable storage hash. So this refers kind of uniquely to the data that's going to be pulled down from the storage database. And then you have a label. Yeah. Where does that live? I think I'll get to that a little bit later. Yep. Okay, so as I showed with Plotly, you can create any Plotly figure and display it as figureL. You can do the same with Altair library. So you create a chart, and then you print the URL or save the URL in some database, and then you can share that. Yes?
I mean, anytime Plotly adds a new feature or something, you have to do things? Or
No.
Like if they have a new chart type or a new
No,
line plot?
I guess they're probably limited in what they can add because they use the Vega Lite specification. And so Plotly, so there's a JavaScript side to this, right? That's, okay, so to answer your question, if there's a truly new feature, then there would have to be an update on the JavaScript side. But Plotly has a JavaScript package. And so similarly, Altair has a JavaScript package that could be updated as well. Yeah. Okay, so here's another example of 3D surface. So this is a more customized library where you can, like in this case, load a BTK file with a red blood cell mesh, and then create a workspace, a volume view workspace, add a surface, add scalar fields to it, create the figure, and then again, generate the figureL. And I actually embedded this on the next page here. And so there's a red blood cell, and it's an interactive kind of plot here. Okay, so question about cachery. So how does that work? So the goal for cachery is to just have, I mean, it would be nice if we didn't have to have something called cachery, if you could just send data up into the cloud and then later retrieve it. I mean, that's the vision. It's like, we don't want to have to worry about that. So cachery is a minimal configuration for upload. You can download from anywhere. And there's a Python client or a command line client with serverless infrastructure, and it's organized into zones. So each lab that is using cachery and FigureL can pay for their own compute resources. So to store a file in cachery, kind of we make it as easy as possible. You just say cachery cloud store on the command line, and then the data gets uploaded to the cloud, and you get a hash out of that. So you can now refer to that data in FigureL or whatever. Or from Python, you can just issue store text or store JSON or whatever. And again, you get the URI out. So retrieving the data from command line, you do cachery cloud load, and then the hash, and then it downloads the data to like a temporary directory and gives you the path to that local file. And you can also load the text or JSON from Python. Yep.
So like pickle, different version of Python might change the so it's like the version.
Yeah.
The version be a feature URL.
Yeah. Pickle is from way back in the beginning phase. It was kind of a mistake to support pickle. Like I never used the pickle feature, and I guess it shouldn't really be on the slide, but really it's, yeah, I think we'll get rid of it. Yeah, I don't think anybody's depending on that. But okay, so here's a gallery. If you go to my GitHub profile page, there's a link to this presentation, and you're welcome to check out those various plots. I thought I had a time series graph example, but anyway, let me click on that one. Oh, it's just an image. It says learn more, but you can't learn more. Yeah. Okay, so there's different things you can check out in the FigureL gallery. Most of these are specific to neurophysiology. And so there's lab-specific visualization plugins as well that are really specific to a particular type of data from the lab. So this one, it's kind of a movie that you can view the position of an animal moving around a maze over time. Here's another one where it's for sound source localization, where it's this widget that includes the ability to curate sound snippets from an animal that's moving around a box. And here, this is actually embedded, I think. There we go. So this is an example from a lab where you can select units. It actually, the pixelation is bad because it's cramming it into this slide. But if I follow the link, you can sort of see that it's, all these are spike events, and these views are synchronized, and then you can click on individual units and etc. Here's another example. So this is not actually used by anybody, but I think it has the potential because you can sort of like label poses, animal poses, and then you could save the results to GitHub. So I'm not exactly sure why I did this, but it's, I think it was supposed to like replace pose estimation that other labs were doing, but I didn't find somebody that was like interested in the web version.
I think it was like a reinforcement learning thing. Like they were going to do a first pass with
yes,
an automated estimator, and then.
Right. Yes, thank you. It was kind of a while ago. And then just to show the range of things that can be done. So here's another example where the animal is moving around the maze or the track, and you can view these other plots that are synchronized to the animal's position. So again, it's something that is nice to be able to share with somebody in just one link, and then they can see that. Oh, here's another kind of cool example where you have a movie of the animal moving around the box, and it's synchronized with these spike times over here. So these spikes are like every time a neuron fires. Well, it's actually, yeah, so these are the individual spikes. And I guess somebody can look at this and they can see what they think the animal is thinking. So
Are these different dogs and characters, each widget pointing to a different?
yes,
Okay.
yeah, they are. But there's a visualization app or plugin that knows how to synchronize them. Yeah. Okay, so the last thing I'll show is that you can also embed the figures into Markdown documents. So here is a sort of paper that I wrote that I wanted to include interactive figures in. So when it comes to doing the interactive figure, I just pasted in the URL, and it would be nice if that interactive figure could be rendered there within the paper. So that's where this other service comes in, doc.figurel.org. So you can point doc.figurel.org to a Markdown document that's hosted on GitHub, and it will render the document, but then when it comes time for an interactive figure, right here, then it loads it. So I think this has potential for like alternative ways to publish things that that can include the interactive graphs. So with that, I think that might be my final slide. To get back to my presentation. It's not getting me back to the presentation, but the final slide is, yeah, I wonder how that happens. Oh, there we go. I need to get to my final slide here. It's very important. Okay. So in summary, a lot of tools exist, but frictionless sharing is still a challenge. And so Figurel tries to reduce the friction to promote the scientific collaboration. And for future directions, obviously we need to expand the number of visualization plugins that are available. So that's where new developers and collaborators are important to attract, and improve the cache-free infrastructure, because there's got to be some more built up there, because it can't just be like a free service where anybody can put a file and get it to come down. So so thank you.
All right, thank you for the nice talk. We have time for a few questions. Yeah, Aaron.
Said something about cachery is serverless. What does that mean?
So it's not like I will never get a notification that the server is down, right? Because there's, how can I explain? So there's an API that's hosted on a company called Vercel, and they host the API, but each call to the API is a stateless operation that takes just a couple hundred milliseconds, that there's no ongoing running server that has to have a certain amount of RAM or whatever. So there is a database, but the API is just a managed kind of service in that way. Maybe other people could explain that probably better, but yeah.
We publish who's managing, like, how long, like is there like a dropout, like, oh, it's been active
Yeah.
for a while, or like, could you put like a URL? So
Yeah, I mean, it's really difficult because we don't want to delete any data, because people sort of have these links around. So we haven't solved that problem yet, but I do have this monitoring service that shows like all the accesses. So at least we're tracking it. So I can see if like, okay, so this person uploaded 71 files, 2.9 gigabytes. I mean, I know them, and that's okay. But yeah, we need to solve that problem somehow. Yep.
All right, any more questions?
Maybe ask about combining two of the talks this afternoon. How possible, the rendering here is not OpenGL, I presume.
But it could be, it should be.
Could it be? I guess was,
Yeah.
and to get sort of the you know, we're watching like a million points at 60 frames a second. That's I don't know if that's more than what you get through these JavaScript renderers and things. I just wonder if there's a way to go there to get some OpenGL into FigURL.
Yeah, I mean, they're totally orthogonal questions. Like, there's no reason why those widgets shouldn't have been OpenGL. It's just I'm not, Jeff and I didn't kind of go down that route, but we use web workers to make it efficient. So everything's being done in a worker thread. Yeah.
Well, you said you used DeckGL for some of them, right? Like the tiling.
Well, yeah, none of the ones I showed were DeckGL,
Oh, okay.
but mainly it's HTML canvas, the 2D context, but it's very responsive because, as I said, everything's being done in a worker thread. Yeah.
All right, let's thank Jeremy again.